Alright, I have just arrived in Wilmington, California, where all the shipping takes place. Everything comes in here in the ports. You can see the cranes way over there for offloading the ships. Here's some of the shipping containers. This is a training facility for the guys that are going to operate these massive forklifts. And they can stack these 6 high, fully loaded with these forklifts. So this concrete is to support all of that. For the training for the forklifts, stacking these shipping containers. And that's why we got to go down 30 inches and build it back up better and stronger. Hi, David Odell with Odell Complete Concrete. There's a drone view of the harbor. Here's the start of the job. The beginning's always the hardest, breaking a hole through it, and then it gets easier as you start weakening the concrete and branching out and getting some of the steel removed. So this concrete's about 6 to 8 inches, we discovered, and it has 1/2 inch rebar at about 16-inch centers. Now take a good close look at the concrete, how cracked up it is. It's cracked at about 1 foot to 2 foot sections, it looks like. So it's basically from the weight that they've been putting on this and the bad soil conditions under it, bad compaction, it's being crushed and compressed down. That's why it cracks that way. Well, basically, we're working to build this back better and stronger. We have an engineered drawing. We have soils engineers that are going to be out here through the whole process once we get to the dirt. Right now, it's just concrete removal. Once we get to the dirt removal, then we'll have a soils engineer on site every day, all day, as we put the dirt back in here and compact it. But we're using a lot of the same native soil to go back in. It just has to be put in properly. This section actually was done not long ago, but this section wasn't. The last time it was done, about a year ago, 2 years ago, it was for the same reason what's happening now to it. It's failing with the heavy loads on it. So this time around, what they're doing is they got engineering involved to come up with a plan and a design that will hold up with this kind of load. So that's the difference. We have soils engineering out here that actually put a plan together. This is just not a concrete contractor coming out here and coming up with an idea.
All right, this is what we got done. Breaking. It's about, I'd say, 8-inch thick. Rebar every 16-inch on center. Number 4.
All the equipment that we're going to be using for the most part on this job is going to be from Sunbelt tool rentals. And this is the first piece of equipment that we got from them. It's a track, and it's a pretty good sized Bobcat, brand new. It's only had like 20 hours on it. It's working really well. We're going to bring in a couple more as we get going on this project. We're going to bring a couple more Bobcats in, a couple more breakers, and a rolling compactor.
Had a little snafu today. Broke a hydraulic hose on this tractor, on the breaker. Nothing too serious. We got this guy, came out, tuned it up for us.
So there are a lot of mobile mechanics down in this area because this is really main industrial hub center for distribution throughout a lot of the United States, or at least half of it. This is the main harbor everything comes into from other countries across the ocean. And you know, that being said, getting guys out here to repair stuff mobily, it's pretty easy, and there's a lot of them. So you have a choice and you get really good service. Now we have a couple more Bobcats in here. Doug's on the green machine from Sunbelt. And then we have 2 other guys, independents, on their machines. We got a Kubota, and then I think that's a Kubota in there, it looks like. This cutting device right here that we're using from Milwaukee, it really cuts it nice. But as I watch this, you notice there's no sparks, and it cold cuts. It cuts really fast when the blade's brand spanking new, but once that blade wears out, to me it looked like it was a little worn at that point, because usually it cuts a little quicker. Those blades, they're not cheap, so you can only get so many cuts out of them.
All right, here we are, and we've gotten a lot done since I think I last took a video. This is all down 20 inches so far. Most of the dirt has been removed. Lots of rebar. Thanks to the Milwaukee rebar cutter, cutting this stuff out went real fast. Their blades are amazing, but I wish they'd last longer. But they cut like butter. Real nice.
So with the engineering, tying it in back into existing was initially on the drawing it showed being rebar doweled, but since all the concrete in this whole area is failing and it's going to inevitably end up all coming out, and then we're going to have to tie back into the new stuff that we're putting in, we had to come up with a solution. How do we tie it in, but when we do removal, how do we not damage the new stuff that we're putting in right now? So basically I came up with an idea of just a full-blown keyway and no dowels. So the engineers went over and they ended up changing it up so that we could do it my way. It's just one input that I had. A lot of stuff doesn't go through, but you know, some ideas are good, and this one was a good one, I think. And that's the way we're going to do it here. Full-blown keyway, 1 foot all the way around the perimeter, dug underneath the existing, and then when we place the concrete, we use a vibrator all the way around to make sure it flows underneath. That way, when we tear out the surrounding concrete, we can just lay it right on that lip, and we can dowel at that time if we want to. But we all know that rebar or steel rust, especially when it's on a cold joint like this. So how long would it hold really a dowel in between 2 pieces of concrete where water can go down? So that's why I really like keyways. Well, I'm on the tractor now. Doug ended up, so I'm down here right now. This is down in California, and I'm in Arizona most of the time. But in this particular scenario, I ended up coming down here. For one reason, it's a nice big job. And another reason, it's about 120 degrees in Arizona. So I had to get down by the coast in the summer. And that's what I did. I came down here. This is my other brother's job, Darren Odell. So I was able to come down and work with him on this one and a couple other jobs as well that you'll see pretty soon here. So we got the roller, vibratory roller compactor, and that's just following up because we got to do this in 6-inch lifts. Well, I'm actually putting it in here about 4-inch lifts just to be on the safe side. There's the soils engineer out here walking around checking the water content in the dirt, because that's a crucial factor in compaction. Is, you know, depending on the soil you're using, how much water's in there when you're compacting. If it's too wet, it's not going to compact well. If it's too dry, it's not going to compact well. Let's take a look at my main man over here, how his compacting is going. How's that going? How's that unit working for you?
I like it, man. You just gotta watch it. If you hit something a little uneven, it'll jump.
It'll
jump.
bounce you off.
It'll come at your feet.
How does it? Have you tried this slow-mo? Maybe it's easier to handle.
You know what? I hadn't, but I usually this grip on it works good when it's up against. Keep it up against the side. That key is to keep that flat.
Yeah.
If it's got an angle on it, it'll want to bounce off. So just like flatten it out like that. That works good.
Oh, right.
But I like it actually. I've used other ones, the ones that's like a jackhammer.
Yeah, the 2-strokers.
I like this better. This is.
It's quiet, nice. And you could flip it over, and it'll still run. You remember the old ones with the gas? If you tip them over and leave them there, they won't start after. You have to wait for the gas to come out of it.
This one starts right on a dime. I mean, every time. I mean, it's pretty tight.
Yeah,
it runs a while on the battery charge.
I like that unit. You know that?
Yeah, I think it's good for sure. Yeah, I'll try it down in rabbit mode.
Yeah, try it turtle. Let's see what that looks like.
I might be able to sit on it a little longer. Yeah, because it wants to run. It does take off.
Yeah, maybe you might have mud. Oh, that's pretty good. Yeah, so it's a good idea to wear steel toe boots when you're running this kind of stuff, like jackhammers, these jumping jacks, anything that's going to be bouncing around your feet. Steel toe boots are a good idea. There is another argument to steel toe boots. You get used to wearing a steel toe boot and kicking things and not having to be concerned with moving your foot because you know it's protected. You get complacent. So now if you never wear a steel toe boot, your feet are going to move automatically when something is getting near them. So in other words, if you don't have your steel toe boot on and you're used to wearing them, you might have a problem. Once we put a certain amount of the native back in, then we're going to go, I think we ended up going 1 foot or 6 inches of road base on top of the native. So a lot of this native ended up going to a landfill, but a majority of the dirt, the native here, just stayed on site, back in the hole. Here's the base going back in, and that's the same deal. It's all about water, putting the right amount of water in the material. A lot of guys will dump the dirt or the base, whatever material they're working with, into the hole, spread it, and then try adding water and hoping that it'll absorb to the bottom of that lift, and it won't. So what we're doing here is we're pre-mixing everything we put in here. We're pre-mixing it with water out of the hole with the tractor, stirring it up, getting the right moisture content in all the dirt and base before we put it in the hole. Now the residual water we're putting on top is very minor compared to what's going into it in the mixing pile. So the nice thing about the soils engineer being here all the time during this process is he let us know when he tested the soil at every stage and the base. He let us know if we had to decrease the water or put more water to really achieve the maximum that this soil can achieve. You notice they're pulling string lines across to check grade. A laser is tough to use in this scenario because we're on a parking lot that has some slope to it, most likely. So your laser level's not going to work that great on something like this. So pulling a string line seemed to work just fine.
Here we are, final roll.
You see that little pile right there? That's one of the test spots. They basically dig out a little hole, take the soil sample, and then they cook it. They have two types of systems they can use to test the soil compaction. A lot of times they're used to use, and they probably still do. It's a rod that'll drive down into a hole that you create in the dirt. You slide that rod down, and then this device emits radiation into the soil, about a 10-foot radius. It shoots that radiation out, and then the amount of time it takes to come back to that probe, that'll tell you the density. But now what they're doing, rather than being exposed to radiation, they're taking the soil, they're going back to the old school style, and that's cooking the soil by, and they know the amount that they've taken out in a core sample, the weight, and then they cook it, weigh it, so they weigh it wet and dry, and that tells them how dense it is. Not sure the exact specifics, but it's called the Bunsen burner, I think is what they're using. Anyway, thanks for watching. Make sure you stay tuned because the big pour is coming up, and that's an exciting part of this whole process.